Hey guys, today we will be talking about the law of conservation of mass and energy and continuity as these things relate to irrigation systems. So, the law of conservation of mass is this concept in physics that means that as water moves through a pipe, the amount of water doesn't change. So, the same amount of water that's exiting the system through sprinkler heads and faucets first had to move through the pipes, valves, fittings, backflow, even further up to the water main, pump house, treatment plant, whatever. So when the pipe branches, the flow splits between different paths, but if you add all of those up back together, it's going to be the exact same as the total amount of water that entered the branch, okay? The law of conservation of energy now is separate but similar. It's saying the same kind of thing about energy. So energy is not created or destroyed. It only changes forms. So in an irrigation system, pressure is an expression of energy, and that can turn into velocity. Velocity can turn into turbulence, and some of that, what's called mechanical energy, becomes thermal energy through friction. Pressure can also become elevation, right? It can be used to do work. So for example, as water flows uphill, some of that pressure is converted into gravitational potential energy. Then as the pipe comes down back downhill, that energy is converted back into pressure. Continuity is the final principle, and that just basically says that because water is essentially incompressible, it's not like air, you can't compress it, its density stays constant, and that goes into some equations that output this idea that flow rate is determined by two things. So Q equals A times V. So A is the cross-sectional area of pipe, and then we multiply that by the velocity of the water moving through it, right? Which is why we have gallons per minute. We're looking at the cross-sectional area, the amount of water in a certain amount of time traveling through that area. So that's also why sprinkler nozzles take pressure inside the pipe and convert it into a high-speed stream of water that travels across your lawn. Because Q is the flow rate, A is the cross-sectional area, and V is the velocity, which means if one of those changes, the other has to change as well. If A decreases, then V has to increase, which means when the area decreases, like in a sprinkler nozzle or when you have a restriction in your pipe, velocity is going to increase. Okay, that's why also putting your thumb on the end of a hose or putting a nozzle on a hose makes the water shoot further and faster. But it also means the opposite is true. Putting your thumb over the hose or putting a nozzle on doesn't make more water come out. In fact, because you're creating a restriction to that flow, less water is going to come out. If you were filling a bucket, for example, it would fill slightly faster without your thumb over the hose, even though the water coming out with your thumb there is moving a lot faster. Water naturally moves from areas of higher pressure inside the pipe towards lower pressure areas outside of the sprinkler head. Once it leaves the nozzle, its momentum carries it through the air, and gravity then eventually decides where it lands on the grass. The same kind of thing happens inside a pipe when there's an obstruction. So let's look at that a little bit. Let's say a bad repair was done to an irrigation line leak, and they got some rocks into the pipe. Those rocks move downstream until they reach a T or an elbow, where their shape causes them to get stuck. Now, instead of water flowing through the full diameter of that 1-inch pipe, maybe it's only able to squeeze through a few tiny cracks between the rocks. That's going to speed up the velocity, but it's going to lower the flow a lot because it's creating that restriction. It's basically like putting a little nozzle inside of the pipe. The water now has to move extremely fast through those small openings to continue with the mathematics of things, but pressure builds up upstream of the blockage. But turbulence, friction, and restriction prevent adequate flow, and they prevent the pressure from reaching everything downstream. Turbulence is a term used to describe water moving in chaotic little swirls instead of flowing smoothly in one direction like we want it to. That swirling motion causes the water molecules to collide with each other and the pipe walls a bunch more, and that wastes the energy as heat, right? That friction that we talked about. On the surface, that usually means sprinkler heads before the obstruction have higher pressure than before the blockage occurred, and heads after it will have a lot worse pressure, which is why sometimes you'll see one sprinkler head or a few sprinkler heads towards the end of a line that have really bad pressure, and then some earlier in the line that have great pressure. What's happening is that pressure energy is being converted into velocity and turbulence inside the obstruction before the water ever reaches the sprinkler heads. That creates an irreversible loss of mechanical energy, turning it all into thermal energy, so we can't use it anymore to move the water. Now, let's compare that to the opposite situation, a leak. Let's say somebody was installing a fence and drove an auger straight through a pipe in a sprinkler lateral line. Now, that's another place for water to leave the system. This is going to behave differently than an obstruction, and in fact, it's going to be the opposite. Instead of restricting the flow, you've increased the amount of flow that the system's trying to supply. It's basically like adding another sprinkler head or a big sprinkler head where the leak is, with the nozzle about the size of whatever hole they created. Now, more water has to move through the shared upstream piping. That creates friction loss through the entire system, and it moves your water source further down its pressure versus flow curve, which we can talk about in another video, meaning less pressure is going to be available. More of the available pressure energy is going to be used up before the water ever reaches the sprinkler heads. The result there, then, is that pressure is going to drop throughout the whole zone, although some heads might be affected more than others depending on where the leak is located. The laws of conservation of mass and energy, along with continuity, explain a huge amount of what happens inside irrigation systems. Conservation of mass tells us that water isn't disappearing. Conservation of energy tells us where the energy is going. And continuity tells us how flow, pipe size, and velocity are all connected. Once you understand those three ideas, everything in sprinkler hydraulics, from nozzles to leaks, obstructions, friction loss, and just general design, start to make a lot more sense.